Peace be upon you. Decimals. Let us start our lesson by watching the following video in order to check where can we find decimals in our daily life.
I am ready for a trip to the seaside, feeling thrilled.
You seem to be very eager and excited, so let's not while away the time. Off we go.
How far we still have to go, Dad?
Let's find out from our GPS navigator.
In 100 meters turn right. Go straight for 53.7 kilometers to reach your destination.
There is still a long way to go, so let's take a quick break.
Dad, can I ask you a question? What did the point in the number 53.7 kilometers mean?
The point indicates that the number is a decimal number.
Okay, but what is the point of the point?
Let me explain, son. To understand decimal numbers, let's begin by looking at some simple examples of integers. 234, minus 78, 0 of course, some big numbers like 854,327, 3,816, and I could go on and on. In the decimal number system, the value of the digits in any number depends on where they are placed. In this particular case, the number 3816 is in fact sum of 6 ones, 110, 8 hundreds and 3 thousands, each having its own place value. And as you move from right to left, you can observe each position to be 10 times larger than the previous place value. We keep going further left, we can represent bigger numbers in the order of millions, billions, gazillions for all it matters. Now let's say we subtract 1 from this number, we get 3815. Notice that the value in the ones place got changed. Add a 60 to this number, we get 3875, with the tens place value getting changed. So depending on what you add or subtract or execute any other operation for that matter, the respective place value of the number changes. But what if we have to add a number that is less than 1? Which of these place values will be affected?
But what can be less than 1, Dad?
Take this bread for example. It was earlier one whole loaf of wheat bread before we made 10 slices of it. So one of these slices here is nothing but 1 part out of 10 parts of the loaf. In other words, a tenth of the bread, written as 1 upon 10. Simple. So coming back to where we were, for anything less than 1, we have to create new place values. For instance, we have the place value 1/10 for any number that represents parts out of 10. For numbers that denote parts out of 100, we have a place value 1/100th. And as and when we require tinier and tinier parts of 1, we use 1000, 10,000 and so on. As we move further right, each position becomes 10 times smaller than the previous place value, exactly opposite of how it was on the other end. So let's say we add 4 tenths and 9 hundredths of 1. But there seems to be a slight problem here. When you see these digits without their place value names, you don't know what the number really is. It actually now looks like 387,549, which it is not. It's impossible, of course, to keep writing the place value names always. We certainly need to find an easier way. That's where our decimal point comes in. This symbol here separates the integers part of the number from the fractional part. So there is what is called as a decimal number.
Great, let me read this. 3875.49.
Yeah, but you don't read it like that. The digits here are decimal digits, remember. They signify a fraction of 1, certainly not an integer. So we read the number as 3875.49 and not 49.
Thanks, Dad. I now get the concept of decimal numbers.
You better do, as you will come across decimal numbers almost everywhere in your life. For example, prices of items you buy or sell, tax calculations, profits and losses, basically wherever money is involved, batting averages in sports, sizes and measurements of all types, scientific and mathematical calculations, your grandma's medicine dosage, even your radio station frequency numbers are in decimal form. Simple, wasn't it?
Great, but I still have one question. Why did you order only bread slices in the diner?
Decimal numbers. A decimal number is a number that has a decimal point. For example, 17.59. Here is the decimal point. To the left side of the decimal point, we have the units, and after that, we have the tenths. To the right side of the decimal point, we start by the tenth digit, and then the hundredth digit. This is called the whole part or natural part. And to the right side is the decimal part. We can represent the decimal number 1.59 by the following figure. In this number, we have one whole unit. It's represented in this square. And we have 5 in the 10th digit. So its place value is 5/10 or 0.5. The 9 is found in the 100th digit. So it's represented as 900 or 0.09. We can also represent the decimal number 1.79 and 17.59 by the following table. This table shows the decimal place value chart. So we have the decimal point in the middle. 1 is found in the 1st digit, and the 7 is in the 10th digit. The 9 is in the 100th digit. In 17.59, we have the decimal point in the middle. To the left side, the 7 is in the 1st digit, the 1 is in the 10th digit, and to the right, we have the 5 in the 10th digit and 9 in the 100th digit. Reading decimal numbers. How do you say 36.57? We have 36 in the whole part. It's read as 36. The decimal point is read as and the 57 to the right of the decimal point, we read it as 57 hundredths. How do you say 4.603? It is 4 and 603 thousandths, since the last digit 3 is found in the thousandths digit. Let us read the following decimal number, 3.45. It is read as 3 and 45 hundredths, or it could be read as 345 hundredths, or 34 tenths and 5 hundredths.